We are going to revise today permutations and combinations. Now, when we talk of permutations and combinations, there are two concepts which form the base of the chapter. The first concept is fundamental principle. By fundamental principle, if one thing can be done in m ways, another thing can be done in n ways, then total number of ways is always equal to m into n. The second concept which we discuss in this chapter is factorial notation. When we talk of factorial notation is denoted by exclamation mark or the letter L or right angle. N factorial refers to product of first n natural numbers. Now, as you have already studied, when we talk of permutations, it refers to arrangements. And when we speak of arrangements, the order is given relevance. Permutations. Permutations is denoted by NPR, which means arrangement of R objects out of N objects. Formula: N factorial upon N minus R factorial. The standard formula of permutation is N factorial upon N minus R factorial. N objects amongst themselves without any restriction can always be arranged in n factorial ways. R objects out of n objects can be arranged in NPR ways. Students, I have bifurcated permutations into types. If you study according to types, it will help you cover maximum number of questions from the ICI module. Type 1, arrangement of objects in a row. When I speak of arrangement of objects in a row, it means in a line. There are two kinds of questions which are asked. One together, the other separated. Let us take an example. There are 5 distinct English books, 3 distinct eco books, 7 distinct accounts books. 5 distinct English books, 3 distinct eco books, 7 different accounts books. Now, my sub question is same subject together. If I want books of same subject together, these are 5 objects. If I want 5 objects to be together, I arrange them amongst themselves, which is done in 5 factorial ways. After I finish their arrangement, they become one set. What do they become? One set. So if I want books of same subject together, English books in 5 factorial ways, eco books in 3 factorial ways, accounts books in 7 factorial ways, and 3 set amongst themselves in 3 factorial ways. English books 5 factorial, eco 3 factorial, account 7 factorial, and 3 set in 3 factorial. Sub question 2. English together. When I want English books to be together, I'll only keep English books together. So English books can be arranged in 5 factorial ways. If you see, there are 10 other books, 3 eco and 7 accounts. 3 eco plus 7 accounts, that is 10 books, plus 1 set of English books in 11 factorial ways. So 5 English books in 5 factorial, 10 other books plus 1 set of accounts English books, that is 11 factorial ways. If I want eco together, 3 eco books in 3 factorial ways. Now how many other books are there? 5 English plus 7 accounts, 12 other books plus 1 set of eco books, that is 13 factorial ways. Sub question 4. Accounts together. There are 7 accounts books. So 7 accounts books in 7 factorial ways. Remaining 8 other books, English plus eco plus 1 set of account books, that is 9 factorial ways. Now if I tell you English and eco together, means I will make a set of English and eco books. There are 5 English books and 3 eco books. So 8 books amongst themselves in 8 factorial ways, and 7 accounts plus 1 set of English eco in 8 factorial ways. Then if I say eco and accounts together, now children, there are 3 eco books and 7 accounts books. So 3 plus 7 is 10. 10 books in 10 factorial ways, and remaining 5 books of English plus 1 set becomes 6 factorial ways. Now, if I ask you English and accounts together, if I say English and accounts together, then total they club to 12. 12 books in 12 factorial ways, and remaining 3 plus 1 in 4 factorial ways. The most important question where generally students make errors, English books separated. When I want English books separated, means I have to place them between eco and accounts. Eco and accounts, children, if you observe, they are 8. So there are 8 other books. Eight other books in a row provide me 9 empty places. These 9 empty places are for English books, which are 5. So 9p5. After my arrangement of English books, there are 8 books which are left, which do not have any restriction. So they can be arranged amongst themselves in 8 factorial ways. If I ask you, eco separated. If I want eco books to be separated, means I have to count the number of English and accounts. They are 12. 12 plus 1 becomes 13. 13p3 into 12 factorial. Now, if I ask you accounts books separated or accounts books not together or no 2 accounts books together, means I consider English and eco. Number of English and eco books is 8. 8 books will provide me 9 empty places. So 8 books provide me 9 empty places. 9 empty places are meant for 9 empty places are meant for 7 accounts books. So 9p7 into 8 factorial. Now here, in the first example, when I wanted English books to be separated, then I had eco and accounts. Eco and accounts all together were 10. So 10 eco and accounts books will provide me 11 empty places. If they provide me 11 empty places, then the factorial would be so friends, coming to the first example, English books separated. If I want English books separated, means I consider the number of accounts and eco books. The number of accounts book was 7. The number of eco books was 3. Total 10 other books which would provide me 11 empty places. 11 empty places for 5 English books and remaining 10 books in 10 factorial. When I wanted eco to be separated, means I don't consider economics books. The number of English and accounts books were 12, which provide me 13 empty places for 3 eco books. So 13p3 into 12 factorial. When I want accounts books to be separated, the number of eco and English books is 8, which provide me 9 empty places. So the arrangement would be 9p7 into 8 factorial. Students, this was the first time where I wanted arrangements objects in a row. Now we come to type 2, where it is somewhat similar to a row, but we'll consider letters of a word where there is no repetition. Letters of a word where all are distinct, all are different. If I want to solve questions of letters of a word, I bifurcate into two parts, consonant and vowels. The number of consonants is 5, the number of vowels is 3. Let us discuss the different types of questions which can be asked in this. First, number of arrangements. When I ask you number of arrangements, it means I want to arrange all letters without any restriction. There are 8 letters. Without any restriction, they can be arranged in 8 factorial ways. So 8 factorial ways, 8 letters can be arranged in 8 factorial ways. Now if I ask you in this sub question 2, 3 letter words, I have 8 letters in all, out of which I want to arrange 3, which is possible in 8p3 ways. Sub question 3, I want 3 letter words excluding T. I want to make a 3 letter word, but I don't want T. So there are 7 letters available. So my answer would be 7p3. Sub question 4. I want 3 letter words including T. There are many ways of solving this question, but the best way is total minus exclusion will give me all possibilities of inclusion. It is like when you solve a question of probability of at least one, it is total minus none. So your total is 8p3, exclusion is 7p3. 3 letter words including T is total minus exclusion. Sub question 5. Something similar to what we discussed in the first question. Vowels together. Triangle is 8 letter word. 3 vowels, 5 consonants. 3 vowels can be arranged in 3 factorial ways. 5 consonants plus 1 set of vowels, that is 6 objects in 6 factorial ways. Sub question 6. Consonants together. There are 5 consonants which can be arranged in 5 factorial ways. 3 vowels plus 1 set of consonants together can be arranged in 4 factorial ways. Sub question 7. Vowels separated. As we discussed in the previous example, students, of English, eco and accounts, if I want vowels to be separated, I ignore vowels. There are 5 consonants which will provide me 6 empty places. So 6p3, remaining 5 consonants in 5 factorial ways. Next, if I want vowels together in a particular order, I want them in a fixed order. If you want something in a fixed order, means you cannot interchange them. So here vowels cannot be arranged amongst themselves. A set of vowels is added to the number of consonants, which gives me 6 factorial. Sub question 9. Vowels occupy even places. Students, this is 8-letter word. The number of even places, if I count, is 4. 4 even places for 3 vowels, which becomes 4p3. Remaining 5 consonants have no restriction, which can be arranged in 5 factorial. For this question, if I take vowels occupy odd places, even if I consider 8 places, then the number of odd places is 1, 3, 5, 7. The number of odd places is 4. 4p3 into 4p3 into 5 factorial. So even odd places in this question does not make any difference. It would make a difference if the number of places is different. Here there are 4 odd places, so 4p3 and remaining 5 letters in 5 factorial. Sub question 11. Number of rearrangements. When I talk of rearrangement, students, remember I cannot include the original word because it is a part of arrangement. It cannot be a part of rearrangement. So the resultant value would be 8 factorial minus 1. Sub question 12. Relative positions of vowels and consonants remain unchanged. When I say relative positions of vowels and consonants remain unchanged, means vowels will remain at their places, consonants will remain at their places, which can be done in v factorial into c factorial. I repeat, it will be done in v factorial into c factorial, which will become 3 factorial into 5 factorial. Now, triangle has 8 letters. If I ask you, begin with T, end with E. To begin with T, first place is fixed, last place is fixed. Remaining 6 letters amongst themselves can be arranged in 6 factorial ways. Sub question 14. Begin with T, do not end with E, means my first place can be filled in one way. At the last place, I cannot write T and E, so my last place can be filled in 6 ways because I cannot write 2 letters out of 8 and remaining 6 places in 6 factorial ways. Begin with T, first place one way, last place I cannot write T, I cannot write E, I can fill it in 6 ways. Remaining 6 places in 6 factorial ways. Then I have begin with T, begin with T, begin with T and end with E we have already taken. I'm really sorry. The last sub question would be T and E. Last question would be T and E at end places. There are 2 end places, 2 letters. So 2 factorial into 6 factorial. Students, with this second type, we have covered all possible MCQs which can be asked on the basis of distinct objects. Now, we come to type 3. Type 3 is also letters of a word, but it happens to be objects where they are repeating, which we call it as alike objects. Now, standard formula for arrangements for alike objects is, if out of n objects I have x objects repeating p times, y objects repeating q times, z objects repeating r times, then I have to nullify the repetition which has taken place. So n factorial is divided by p factorial, q factorial and r factorial. Let us take an example. Let us take the word mathematics. If you take the word mathematics, total number of letters is equal to 11. M repeating 2 times, A repeating 2 times, T repeating 2 times. Now if I want to find number of arrangements, total factorial upon number of times a particular object is repeating, 2 factorial the whole cube. If I ask you 2 A's together, when I take 2 A's together, I set apart 2 A's. 2 A's are set apart. Now the number of letters which are left is 9. 9 other letters plus one set of A in 10 factorial, out of which there are 2 letters which are repeating but not written over here, that is M and T. So 2 factorial the whole square. Now if I consider these 2 A's, they are alike objects amongst themselves. They can be arranged only in one way. If I take A's together and M's together, see the statement properly. A's together and M's together means I have one set of A and I have one set of M. Now 4 letters are kept aside out of 11. Remaining 7 plus 2, that is 9 factorial upon the letter which is repeating but not considered over here. That letter is T. So 2 factorial. Now within themselves, 2 A's can be arranged in one way and 2 M's can be arranged in one way. Sub question 4. Sub question 4. All A's and M's together. Now children, here in a single set we put all A's and M's. 4 letters are kept aside out of 11. Remaining 7 plus 1 set, which is 8 factorial upon 2 factorial for T. And now if I consider them in this circle, neither they are all distinct nor all alike. So I consider the number of objects as 4 factorial, out of which M is repeating twice and A is repeating twice, which becomes 2 factorial the whole square. So students, with this we have finished the third type. The fourth one in permutations is circular permutation. Now remember, when I want to arrange objects in a circle, I fix the position of one object. So I have to arrange only n minus 1 out of n. N minus 1 objects amongst themselves can be arranged in n minus 1 factorial ways. Standard formula of circular permutation is n minus 1 factorial. But whenever you come across beads, necklaces, no two same neighbors, again my formula will be n minus 1 factorial upon 2. Why is it so? In normal circular permutation, clockwise and anti-clockwise, they are two different arrangements. But in beads and necklaces, clockwise and anti-clockwise do not give me two arrangements. They give me one arrangement. So every 2 will become 1, 10 will become 5, 20 will become 10, 100 will become 50. N minus 1 factorial will become n minus 1 factorial upon 2. Let us consider an example. Normal circular permutation. 8 friends seated on a circular table. First, number of arrangements. It would be by virtue of standard formula 7 factorial. Sub question 2. A and B together. If I take A and B together, A and B amongst themselves can be arranged in 2 factorial ways. 2 friends are already considered out of 8. Now there are 6 other friends plus one set of A and B. Together club 7 objects. 7 objects in a circle can be arranged in 6 factorial ways. Sub question 3. A and B separated. If I ignore A and B, remaining friends are 6. So remaining places will be 6. 6 places for A and B, that is 6p2, and remaining 6 friends in a circle by standard formula can be arranged in 5 factorial. So friends, in this circular permutation you have to keep only one thing in mind. Whatever is n in a row becomes n minus 1 in a circle. Sub question 4. A on LHS of B means I have to assume A is on immediate left hand side of B and they cannot be interchanged. So A and B amongst themselves in one way. Now we have 6 friends plus one set of A and B, 7 objects in a circle in 6 factorial ways. Sub question 5. A and B on either side of C. If I take A and B on either side of C, C in one way, A and B in 2 factorial ways. Now 5 friends are left. Total number of objects is 5 plus 1, 6. 6 objects in a circle in 5 factorial ways. So this ends permutations discussion. Now we will go ahead with discussions of combinations. Now we go ahead with combinations. Students, combinations is a very small topic in comparison to permutations. Combinations, the standard formula, combinations refer to selections. The standard formula of combination is NCR is n factorial upon n minus r factorial into r factorial. With the help of combination, we can relate permutations. Number of permutations is number of combinations into r factorial. Now, there are two properties which are extensively used in combinations. One, if NCX is equal to NCY, then X is equal to Y, or X plus Y is equal to N. The questions which can be asked on the basis of this: NC5 is equal to NC7, find 13CN. Now if NC5 is equal to NC7, then 5 plus 7 is equal to 12. So the value of N is 12. So 13C12 will be 13C1, which is equal to 13. Because NCR is always equal to NC n minus R. Second example. 10CR is equal to 10CR plus 4. Find 5CR. Now here I can use the property of NCX is equal to NCY, then X plus Y is equal to N. R plus 4 is equal to 10. 2R is equal to 6. R is equal to 3. So 5C3 is equal to 5C2, which becomes 5 into 4 upon 2 into 1, which becomes 10. These are the questions which can be asked on the basis of the first property. Second property, NCR plus NCR minus 1 is equal to N plus 1 CR. Now, if you try to by heart this in terms of N and R, it is 100% sure that you will forget the property. Remember, this property is applicable when both the values of R are consecutive and N is same. I repeat, both the values of R are consecutive and N is same. Say for example, 13C4 plus 13C5. R is consecutive. What is the result? Out of the two consecutive numbers, the greater value of R remains as it is and N gets added by 1. So 13 eventually will become 14. The second type of example which can be asked is 10C2 plus 2 into 10C3 plus 10C4 is equal to 12Cx. Now remember, if I am finding x which is in the place of r, x could have two answers. One, the answer which we get on comparison, and one, the difference of 12 and that answer. Now 2 into 8, 10C3 can be written as 10C3 plus 10C3 plus 10C4. 10C2 plus 10C3 can be written as 11C3. 10C3 plus 10C4 can be written as 11C4. 11C3 plus 11C4 can be written as 12C4. So if I compare 12C4 with 12Cx, x is equal to 4 or x is equal to 8. Difference of the two. These are the two properties which can be asked in combinations. Then from combinations, what you have to remember is applications. First, if there are n points, number of lines, a line minimum requires how many points? 2 points. So NC2. Number of triangles, triangle requires 3 points. Second, out of n points, if P are collinear, out of n points, if P are collinear, then the formula for number of lines is NC2 minus PC2 plus 1. Why is this formula in such a way? Out of n points, the maximum number of lines which I can make is NC2. But suddenly I come to a conclusion that P points are collinear. Means the number of lines made from those P points are incorrect. I have to subtract those wrongly included lines. So from NC2, I subtract PC2, but when I take collinear points on a line, they make one single line. Therefore, it is not that those collinear points do not make any line. They make one line. Therefore, we add 1. Number of triangles will be NC3 minus PC3. Number of triangles, we just subtract the triangles from those collinear points because collinear points do not make any triangles. So, we do not add 1 also. So, wrongly included triangles are subtracted from total number of triangles and that's it. Then, number of diagonals of n-sided polygon. If a number of diagonals for n-sided polygon, we have to remember the formula is NC2 minus n. 10-sided polygon, 10C2 minus 10. 20-sided polygon, 20C2 minus 20. 15-sided polygon, 15C2 minus 15. Fourth, number of handshakes. The moment you come across the word handshakes, the formula is NC2. Because 2 people, 1 handshake. 3 people, 3 handshakes. 4 people, 6 handshakes, which becomes NC2. If there are n distinct objects and I want to select all, it can be done in one way, NCN. If I want to select if I want to select all objects, the number of ways in which it can be done is 1. If I want to select objects where I may or may not select, then my selection starts from 0 and ends at n. Whenever my selection starts at 0 and ends at n, the direct formula is 2 raised to n. If I want to select one or more objects, which I can say at least one, then number of ways will be 2 raised to n minus 1. If I want to select r or more, then this can, I start my selection with NCR and I end my selection at NCN. All 1, I am not sure, 2 raised to n minus 1. If I want to select minimum 1, if I am not sure, 2 raised to n. If I want to select minimum 1, 2 raised to n minus 1. And if I want to select at any other number, I should start at that number and stop at n. Just to recap, lines NC2, triangles NC3. Out of n points, if P are collinear, lines NC2 minus PC2 plus 1. Triangles NC3 minus PC3. Diagonals of a polygon NC2 minus n. Handshakes NC2. If there are n distinct objects in front of me, I want to select all, 1, I am not sure, 2 raised to n, I am sure at least 1, 2 raised to n minus 1, and if it is r or more, I start at r and stop at n. Friends, whatever we have discussed in permutations, combinations, these points would be more than enough to help you score maximum marks. Thank you.